I would like to give a brief introduction to R and provide some coding examples. R is a language originally developed for statistical computing and graphics. It was implemented after an earlier language called S from the Bell Labs. R has been very widely used, and lots of packages for statistics and data visualization have been developed for it. Today, R is considered one of the major languages for data science. Because R was designed for statistics and data processing, it has in its very nature the capacity to deal with complex data structures in a very simple and intuitive manner. For non-programmers, this is great news because you can compute numbers, vectors, and even matrices easily without coding in complex programming structures such as loops. Personally, as a researcher, I love the high-quality plots produced by R out of box, among many other features. So let's take a look at R in action. I recommend that you install RStudio in addition to the R project environment. RStudio is an integrated environment that makes it easier to code and test your R programs. When you open RStudio, this is the default interface you see. On the left side is a console where you can interact with R, typing the code in and get results immediately. On the left, there are views in which you can see variables and values in the environment, and things such as help, files, and plots. Plots, for example, is where you can see the figures produced by your code. For now, let's focus on the console and see what we can do with R. You know R is good at computing, so let's make it do some computation for us as if it's a calculator. So we can put 2 plus 2 into the console, hit enter, and R is going to give you the answer for the result of this computation. Certainly you can do other arithmetic calculations such as subtraction, division, multiplication, and so forth. You can certainly try a little bit more complex ones such as this and see what result R can give you. Now, as a programming language, R is capable of saving the result into a variable. Okay, so we can create some variable and store the result to it by using this less than minus notation. This is an assignment notation which is going to get a result on the left side, in this case 2 plus 2, and which becomes 4, and assign the value of 4 to x. Okay, so after this R step, and if you type x and hit enter, it's going to show you the value of x, which is 4. Now this is equivalent to x equal to 2 plus 2. Okay, so the equal to symbol and the less than minus is the same. They are both operators to do the assignment of value to a variable. You can do the same thing to y, for example, by subtracting 3 from x and assign the result to y. If you type y, hit enter, you get the result. You get the value of y. So this is assignment and storing values in the variable. In the examples earlier, it was all about integers. Okay, they are numbers. And if you want to take a look at the type of the variable, you can use this class function to see what type x variable has, and can do the same thing for y to see what is the type of y, and they both show numeric. If you want to force the values into integer, you can actually do something like as integer 2 plus 2, and in this case the value was built the value of x is still 4, but if you type class x, it's going to show you integer. So numeric is a very generic type in R, which allows you to compute numbers, but integer is more specific. If you do want to limit your computation and operations to this particular type, you can use the as integer function to do that. But in R, you can also compute with many other data types. So, for example, you may be able to compute the result of 10 divided by 3 and assign to x. So in this case, s is a decimal number, okay? Or you can assign a logical value, such as true, to x. Okay, so in this case, x is either true or false. You can also use a character type in R for variables. In this case, you need to use the quote-unquote to enclose the value in the character string. So in this case, app name is assigned the value of John. So far we have talked about variables with single values, but R can deal with more than just one number at a time. So let's talk about vectors, for example. So we can actually assign to x multiple values together. So in this case, I want to assign a vector of 3 values, 1, 2, and 3, to x. Okay, so now x has multiple values in it, 1, 2, and 3. And you can do the same thing for other variables such as y, 10, 40, and 90. So y has the 3 values here. Now, here comes the power of R. You can perform any arithmetic operations on the vector. So for example, you can multiply x by 3, which is going to multiply each individual value in x by 3, and so the whole vector of x becomes 3, 6, and 9. So then you can assign this computation to another variable called x3, and x3 will have the result in it as a vector. Moreover, you can perform these operations on 2 or more vectors. For example, you can take the vector of y divided by the vector of x, and that's assign the result to z. And you can see the result of z. And so each individual value in vector z now is the division of the corresponding values in vector y and x. So basically, the first value, 10 in z, if we take a look at the y vector and x vector. So the first number in z is 10, which is the result of the first number in y, which is 10, divided by the first number in x, which is 1. The second number in z is 40, which is the second number in y, divided by 2, the second number in x, okay, and so forth. Okay, so you get the idea. Now, please note that x and y are of the same size here. That is, they have the same number of members or values in them. So the computation can be done member-wise. Here we only have a very small collection of values. But imagine you have a much larger data set where you have thousands, if not millions of values. You can still do the same thing. So this is about vector. A vector is a one-dimensional because it only has one set of values. We can also have a matrix in R, which is two-dimensional. You can think of a matrix as a table with rows and columns. And this is one way by which data can be represented. So with the discussion on vectors, we know we can use C and have multiple variables combined into a vector. And we can assign this vector to a new variable such as V. So after this assignment, we know V has the values, 6 values in particular, from this assignment. For now, let's assume the data should be instead organized into a two-dimensional matrix, such as a 2 by 3 matrix. So in this case, we can use the matrix function to convert this one-dimensional 6-value vector into a 2 by 3 matrix. Okay, so with the matrix function, we can use matrix, and then the first parameter in the matrix would be the data you want to provide as input. And then in terms of the outcome, you should specify the number of rows with n row and the number of columns with n col, and then by row equal to true. Okay, so if we hit enter, as you can see, it shows you a 2 by 3 matrix. And we can actually assign this matrix into a new variable called M. And M has a 2 by 3 matrix with all the 6 values are reorganized in this space. Lots of computation can be done directly on the matrix. But in case you would like to single out some of the rows and columns, you can do, for example, M square bracket 1 comma. If you hit enter, it actually shows you the first row of the matrix. So by the same token, you can do M2 to show the second row. If you want to single out a particular column in the matrix, you can do M square bracket comma 1 to bring out the first column, M bracket comma 3 for the third column. If you want to get to the value of a specific cell in the matrix, you can specify the index for the row and column, such as M2, 2 to get the value at the second row and second column. So this is a matrix. This is also a type called list, where you can put various different types of variables of different sizes in it. For now, I do not want to get into the detail of a list. We may come back to it when there's a need for it in particular. But I would like to discuss another structure called data frame, which is used almost everywhere in R. It is basically a list of vectors of the same size. It is a very common approach to access data in R, and it is part of many built-in functionality of R. For example, you may have a small data set about students taking a course with their IDs, names, age, and gender information. Let's suppose we have 6 students in the class, and the IDs are just sequential numbers, just to make a simple example. Let's suppose these are the data values for ID, name, age, and gender. We have 6 students in the class, so each variable has 6 values. ID has a value from 1 to 6. Name has 6 different names in the class. Age has the ages of the students, and gender about gender information of the students. A couple of notes here. So we use a logical type with true or false for the binary case of male versus female for the gender variable here. You can certainly use false for male and true for female if you prefer that way. Although different in type, each of these variables has 6 values. Usually values in the same position or index belong to the same data instance. For example, this first data point is with ID 1, and the name is Matt, and he is 18 years old, and gender is true in this case, meaning a male. So, and the second is to Mary, age 20, and female. So the numbers and values are corresponding. Now, you can combine these 4 variables into one data frame using data frame function. So we can use data.frame ID, name, age, gender, the names of the variable, to put them together, and we can assign the result of this combining to something called my data. So right now, if you look at my data, you're going to see that all the 4 variables and the values are in it. And the variables now become columns in a data frame, as you can see with the names of the header. And also notice that there is one additional column about the row number. Okay. Now, you can reference a particular cell using the same mechanism we discussed with matrix. For example, if you type my data 3, 3, you can get 19, which is at the 3rd row and 3rd column in the data frame. But the common way is by the names of the columns. For example, we can use my data, $, and then the name of the column, such as age, to bring out the values for the age variable in the data frame. We can do the same thing for name. We can do the same thing for gender. And then you can reference a particular value by its index or position in that variable. For example, I can use my data $name to reference the name variable and all its values. And I can provide this index 3 to reference the particular value in the name, the 3rd person's name in the data frame. And this will give you Lucas. So this is a very brief discussion of what we can do with R. Now let's bring back the environment view. And as you can see here, that as part of your coding and executing the code, the environment view can keep track of the variables that you have created and their values. And it's actually a good place for you to see those actual data that have been loaded in memory and to examine them to see if they are consistent as expected. Okay, so we discussed data frames. And in the previous example, we provided the data by typing the numbers in. But in real situations, most likely you're going to load data from external files. So let's take a look at how we can load data from a file into R and process from there. Particularly, let's look at the CSV format or the comma delimited data and how we can load that kind of data file into a data frame in R. So to load data from file, you need to know where the file is. And it is important to know that where you are or where your current working directory is. So to know where you are or your current working directory, you can use this getWD function. Enter. So it shows my current directory is on my desktop. And given that I have already downloaded the data and put it in the desktop directory, this is actually what I want. If not, if you want to change your working directory, what you can do is to use this setwd and then type in your new working directory. Setting the working directory can make it easier for you to deal with the external files, because you do not have to specify the entire path to the file. If the file is already in your current working directory, you can just provide the name of the file without anything else. Okay, now that we are here, let's take a look at the data that I have. This is called CPU performance .csv, and I will provide a link to this file so that you can download the data as well. Let's view the file for now. And as you can see, the first line in the data set is the columns, the names of the columns, which include the vendor and other CPU hardware configurations or factors that can influence the performance of the CPU. And finally, the CPU performance score. So most of the columns have values that are numeric. And so let's see how we can load this file into a data frame. So to load the data in CSV into data frame, we can use read table. So there's a read.table function. And in the function, you need to specify the name of the file. So CPU performance.csv. Because the file is in my current working directory, I only need to provide the name of the file. I also need to tell the function what is the delimiter. So SEP is for me to specify what the parameter is. Here it's comma delimited, so I'm going to say comma. And then header is true, because as you can see, the first line is header information, or the names of the columns. So I can use this read.table to read the data file, and ultimately I want to use a variable to store all the data in memory. So I can create this CPU variable and use assignment operator to assign the read table output into this variable. Okay, so after this, if I type CPU, it's going to show me that all the data have been loaded into this CPU, which now is a data frame variable. So with this CPU variable as a data frame, I can actually take a look at individual vectors in this data frame. And so what you can do is you can type CPU, and then we know there is a performance column. And so if we use CPU $performance, this will bring out the column, or single out the column for performance scores. Okay, you can do the same thing for the other columns and take a look. You can get to specific values in that column or in that variable and examine that. But just to show you some useful function in R that can help you take a look at the distribution of the variable. Just to take an overview of the variable, you can use this histogram function, or HIST function, to visualize the distribution of each variable. Okay, so if we type HIST and then CPU $performance, this is going to show the distribution of the CPU performance scores. So this is the histogram for CPU performance. You can do the same thing for other variables such as chmin. So it shows you the distribution of the variable. You can also do a plot, a scatter plot between any two variables. So for example, you can use the plot function, and the first parameter is CPU performance. The second parameter, let it be cache. So we are going to show the scatter plot between CPU performance and the size of the cache. So this shows the scatter plot, and you can of course plot any two variables together. Now if you want to show a matrix of scatter plots of all the different pairs of variables, an easy way to do it is to use this pairs function, where you can just put the CPU data frame variable as the parameter, and it's going to show you the scatter plot, the pairwise scatter plots between all the variables. So this is an easy way to take a quick look at your data. Of course, for now in this screen, the plot is very small and it's hard to see, but of course you can maximize this on your screen and take a closer look. So these are some initial functions for data visualization with data frame and loading data. In the end, some notes on how to get help within R. If you don't know where to start and would like to browse documentation and related topics, you can use help and start. And this will take you to some initial introductions of R, as well as some categories of R tutorials that you can start with. If you know a specific topic that you would like to read further on, but you don't know more specific about it, you can use 2 question marks to do a search. So for example, if I'm interested in finding out more about the notion of matrix and how to deal with matrix, I can use 2 question mark matrix, hit enter. It's going to show you the various help pages about the topic of matrix. If you know more specific about that topic, so for example, if you know a function, but you don't know how to use that function, you can certainly use 1 question mark. And then, for example, if you are wondering how to use the function plot, you can then type question mark plot, and this is going to get you to the specific page, help page, about plot. And so you can read about the different parameters with plot and examples about how to use this plot function. That's it for now. Let me know if you have questions or issues. See you next time.